Hey there, welcome to part 2 of the problem solving and creativity lecture. Again, this is still one of my favorite topics, and we're going to go through things a little bit deeper than we did on Monday. So we talked a lot on Monday about the Gestalt approach and the idea of thinking outside the box and changing the way that we think and manipulating the ideas and how that can really impact our success with solving whatever problem we're faced with, right? So that was the Gestalt approach. There is another approach that's available. It is the information processing approach. So instead of just considering that initial state, that we talked about, the state that we're in, the problem, and then the area in between, what we now do with the information processing approach is that all those spaces in between are actually important to solving the problem. So we talked about the aha solutions, right? Or the math problems. So this is going to play more in with the math problems, things that have a structured, organized way to solve them. I think one of the best ways to show it or to talk about it is something called the Tower of Hanoi. So it looks like this. Bing! Tower of Hanoi, right? So we have 3 different pegs, and for the very basic example that we're going to give, one of them has 3, none, and none. So the idea is to get all of these, maybe these, I think it's probably this way, doesn't matter. Wherever it is, the one with the thingies on it, all of those to get from that first peg to the last peg. But there's a couple rules. The first rule is that you can only move one at a time, and you cannot, I think you can only move one at a time? Right. Yeah, and it has to be in the right order. Okay, sorry, my brain went dumb there for a second. So where this all came from, this is an actual thing. This is something that is done by monks in a monastery. But with theirs, it is 64 different rings on a peg that they need to get all the way to the end. The idea is, or the myth, or the folklore, or whatever legend, whatever you want to call it, is that when they are successful with this, the world will end, which is their goal, I guess. To me, it sounds like a horror movie, but for them, this is their goal. But fear not, it will take, even if they make one move a second, it will take 1 trillion years before they figure it out, but it's good that they work on it. So the idea here is that you have your initial state. So that's the 3 pegs on the one, and you need to move all the pegs to the left. Then you have your goal state, which is to have all of them to the left. Now, in the information processing approach, each subsequent step is part of it. So those are intermediate states. So those are the conditions at each state. When you move one of the pegs or one of the rings to another peg, intermediate state. Move another one, intermediate state. The operators are going to be things that are the rules set by it. So the idea that you can only move one at a time, okay? And then the means and analysis, this is the way of figuring out how to get to your goal and your sub-goals. So you want to free up one, go to the next. So I want you to go in, and move this so I can give you the right information, to the in-class supplements, and it is the, there you go, Tower of Hanoi. It's going to look like this. So move one disc at a time from one peg. Can only move disc when no discs are on it. Larger disc cannot be put on a smaller disc. I forgot that one. I knew I was forgetting one. All right. So, go ahead and do that. Now, I will wait, and then we will come back. All right. We're back. Did you figure it out? All right. So there are a couple different ways that we could solve it that you can go through. One of the more typical ways would be that the small one goes onto the end one, the next one goes on the middle one, the small goes on the middle one, the big one goes on the end one, the small goes on the first one, the middle to that one, and then on top. All right, so how'd you do at it? So in this state, we are definitely focusing on the steps in between because they're super important. It's obvious in this example why that's so important. But another important process of this is, we talked about changing things up in your mind, right? And looking at it from different perspectives, thinking outside the box. But sometimes it is also the way that things are presented to you that's going to make a difference, right? When there is a problem, the wording of things, the presentation graphically, visually, whatever, can play a role in solving something. So the next problem for you to explore is the mutilated checkerboard problem. So this, boop, is the idea of the mutilated checkerboard, right? So we have a checkerboard, you're familiar, and two pieces are going to be taken off of it, same color. So what you want to do is if you have a domino, can you put that domino on every square without missing any? So you can't put it over a blank one. Each part of the domino has to cover. Are you able to take that and put it over it? So there are a couple visual representations, and I will put in the access to it to determine who will get to see which part of it. So there's a blank board, there's a color board, there are words, or there is bread and butter. So based on the visual presentation that you're given, I want you to come up with if it's possible. All right? So why don't you hop into Blackboard and you'll either see blank, color, words, B and B. Those are for you. Figure out if you could solve that problem. I will take a time out and think about all the things. All right, so how'd you do? Research shows that if you are part of the bread and butter group, you are going to have an easier time or come to the realization quicker. So that was a visual representation. So now, let me put it this way. And you'll see the difference in how information is presented. In a Polish village long, long ago, there was a priest that decided that it would be super important to get all of the men and all of the women in the community married to each other. Okay? So there were 32 men, there are 32 women, and they married each other. 32 very happy marriages. So one night, two men, being men, go to the bar, and they have a competition about who could eat the most pierogies. They're stuffing them all in, okay? Both men die of pierogi poisoning. I don't know. So, can there still be an equal number of marriages? Can there still be all of the men and all of the women in that town married? This one seems pretty obvious, right? If we're going with male-female marriages, there are 32 women to start with, 32 men to start with. Bam! Easy. Two of the men died. So we have 30, we have 32. It is the same problem that you were just given with the checkerboard reworded. You have 32 possibilities with the domino and only 30 squares to cover. Same thing. But when you word it in this way, it becomes much more obvious. So that's just something to think about. Another idea is how we can transfer the analysis, right? So the same idea. We have the analysis of, if I told you that story about the Polish pierogi eaters, for those that don't know, apparently I say it wrong from a Dunmore accent. We call them pierogis. It's, Mrs. Cheese, whatever those little bundles of mashed potatoes and cheese and a delicious pasta dough. That's what I'm talking about. It's not really important. Anyway, so let's go on. How we sort of get primed, right? We talked about priming is super duper important. So the next step, I want you to go in and two different things. Half of the group, so what I will refer to as those that like to sit in the back of the class, right? So it is, let me get, where's the release conditions? Make sure I have it. Stand by. There we go. Okay. So this is Hannah, Maureen, Rebecca, Ava, and Paige. You guys are going to first read up on Fortress. Okay, so again, it's in the in-class supplements. I want you to read through that. And then, and this is where everybody else comes in, okay, so those that are not reading Fortress, you skip that step and you go right to the radiation problem. So I want you to think about this. How are you going to solve it? Okay, go do it, think about it, come on back when you're done, but not too soon. Don't cheat. I'll wait. All right, did you read it all? Okay, so what did you come up with? What's your solution? So for those that did not have access to the Fortress, the idea is, well, let me read the Fortress one. So the Fortress story is that, move this over here. Okay. A small country was ruled from a strong fortress by a dictator. The fortress was situated in the middle of the country, surrounded by farms and villages. Many roads led to the fortress through the countryside. A rebel general vowed to capture the fortress. The general knew that an attack by his entire army would capture the fortress. He gathered his army at the head of one of the roads, ready to launch a full-scale direct attack. However, the general then learned that the dictator had planted mines on each of the roads. The mines were set so that the small bodies of men could pass over them safely, since the dictator needed to move his troops and workers to and from the fortress. Yes, so bombs wouldn't go off if it was just small amounts of people because he had to get his troops in. There it is. However, any large force would detonate the mines. Not only would he blow up the road, but it would also destroy many neighboring villages. So it therefore seemed impossible to capture the fortress. However, the general devised a simple plan. He would divide his army into small groups and dispatch each group to the head of a different road. When he was ready and he gave the signal, each group marched down a different road. The group continued down its road to the fortress so that the entire army arrived at the same time. This way, he was able to capture the fortress and overthrow the dictator. So a little visual there. Can you see it? That's the fortress. Okay. So, I would assume that the group that read that first came up with a solution to the radiation problem. Now that you know it, and if you didn't have a solution, did you come up with it? Point the x-ray from different areas, right? So because we heard the story about the general going in and now coming from all different areas, that's already in your head. So how the information is presented is so important to this success. On to the next one. Ooh, creativity. All right, so creativity. Cute little story for it is the idea of there was this student that was in physics and they were studying the impact of barometric pressure and how that can be used beyond just basic weather things. So he was in a class with another professor and he was asked to provide a demonstration using physics knowledge on how the height of that building can be determined using a barometer. So, first thing he did, the student, he went to the very top of the building and he dropped that barometer right off the top of it. And he used that, the time based on it, and using the gravitational constant, he was able to determine how far it fell. So the professor did not like that answer because that's not what he was looking for. So instead, what the student did is he put the barometer on the top of the building in the sunlight and measured the shadow, and then measured the length of the shadow on the building. And through that, he was able to determine the height of the building. What he did here was not incorrect, right? It's not what the professor wanted him to do, but it's what the professor asked him to do. He didn't clarify how he should use it, or that he should use barometric pressure or anything like that. He simply said, these are your tools, use physics. And he did. That's creativity. The student knew how to answer it the way that he wanted, he just chose not to, right? So what is creativity? It's any sort of divergent thinking, but typically it's also useful. So when we think about anything that's made by people, so let's talk about Picasso, Shakespeare, Beethoven. Is that creativity? Is it useful? Is that a subjective thing, or is it an objective thing? So how do we develop creativity? Can it be developed? If you are sitting there right now and you're like, gosh darn, I do not have a bit of creativity in me, you're wrong. It can be developed. So here's a little test for it, or a little game fun thing. It trains the mind. This is something that my dad used to do when we were little. I absolutely loved it. Pen, pencil, whatever it is that you want, piece of paper. What you're gonna do, it's very difficult, so pay attention. Scribble. Scribble all over it. Get all the scribbles in. Woo! Scribbles. Boom. Pretty good, right? I know. So, all right, I scribbled on a piece of paper. Now comes the fun part. So you're going to do this. Take a time out. Go get some paper. Go do some scribbles. I'll wait. Okay, you got your scribbles? Perfect. Now, get a different color. No, purple. Here's what you're going to do. You are going to take a second and look at the scribbles and tell me what you could find. Let's see. Okay, let's see. Okay, so my first find is not the best. Settle down. So, just a cute little bear. It's a bear. It's whatever. I almost always find a duck. Like there has to be a duck in here somewhere. Duck, 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 duck. Anyway, it's gonna bother me. There's always a duck. A very basic one. We got a hat, like a little cowboy hat. That was my cowboy music. Cowboy hat. Right? So that's what I want you to do, because I can keep doing this forever, and you don't have time to sit and watch that. So what I want you to do is I want you to go ahead and take a second to see how many little images you can find in there. See how difficult it is for you. Go ahead. I'll wait. All right, so how'd you do? I'd ask you to show me, but that's just not feasible right now. So that's how you can train creativity. So there is some thought process behind it. If you go into some of the other things from the in-class stuff, right? The idea that we can create a story based on sharing different ideas, that we create this life force around it. But the idea is that if you are given things like in object creation, so the idea is that you go in there and you get to create an object. Go ahead and if you want to. Some people have more difficult time taking things that are already given to them than allowing their brain to be free and just go out and be creative. So with that, I say, go ahead and practice a little creativity every day. Okay? Start thinking outside the box. have a little fun with it. Do a little doodle every day. Other than that, I think that's all of it. Yeah. The biggest thing for you as the educator that you should, bring into your classroom from this lesson is the understanding that your students are going to come to solutions differently. Celebrate that. Don't force them along the same pathway. If they're getting there, that's great. That's the end goal, that end state. So celebrate that they got there. Focus on identifying the problem and then discovering the solution, right? Use external representation when possible. Put it in different modes for them to think it through. And for very difficult problems, mimic your strategies, right? As you're going through it, be verbal about how you're solving it. There are components that are in our brain that we don't even realize that we're doing, right? We're skipping over them. So talking out loud so your students can see it and understand it is going to be so important. Finally, make sure as often as you can, you take the tasks that your students are learning in the class and apply it to real world situations. So that way it's taking the creativity, this problem solving, and showing them that they can apply it outside of this homework, this assignment, this test. All right? Above all else, just celebrate it. Celebrate the weird. Enjoy.